Now, I would like to talk about our research on the multiple arterial pore structure of vascular access hemodialysis catheter reduces suction towards the vessel wall. I'm assistant professor of Niigata University of Health and Welfare and visiting researcher at Niigata University in Japan. Dr. Oite, Dr. Yamamoto, and Dr. Narita are members of this research. Hemodialysis catheters are primarily used for vascular access in patients with CRRT. In this research, especially, we thought of doing my research focused on vessel wall suction due to hemodialysis catheter. This slide shows vessel wall suction due to hemodialysis catheter. Please look at this figure. If catheter suction vessel wall change like this phenomenon causes serious troubles. For example, blood flow decrease, and coagulations, and thrombus formations. And finally, we cannot continue hemodialysis therapy for patients. We aim to investigate whether the arterial pore structure on the catheters and influence vessel wall suction. We believe that we can supply trouble-free catheters to patients and medical staff. This slide shows 5 kinds of catheters tip. These catheters tip were compared. At first, arterial is the widest catheter, about 5.2 millimeter. Gum cath has only one end hole. Gentle cath has the 2 longest side holes. Jumi N has 1 side hole and 1 end hole. And Niagara Slim has only one end hole. This slide shows catheters evaluation system. 2 blood pump was used as a blood purification machine. The blood pump flow rate was set at 100 milliliters per minute. Catheters were connected to the blood circuit. Extracted pig vein was used. Catheters were inserted into ex vivo pig vein. The pig vein was connected to the blood circuit and filled with 50% glycerol solutions, circulating at 700 milliliters per minute. This slide shows reducing vessel wall suction. The catheter's arterial pore was positioned near the vein's wall around here. When the catheter's pore was suctioned towards the vessel wall, we tried to reduce the direction by 30 degrees per second. The number of vessel wall suction improvements was counted. These results were evaluated in 10 experiment replications. This slide shows the vessel wall suction improvement. Vertical axis shows the vessel wall suction improvements. The other hand, horizontal axis shows the rotating angle. The telealysis, gentle cath completely improved by rotating 90 degrees. Telealysis and Niagara Slim completely improved by rotating 120 degrees. the other hand, gum caps and the chewing end greatly improved by rotating 180 degrees, but it's not complete. This slide shows a ratio of vessel wall suction improvement following 180 degrees rotations. According to these results, it is thought that the arterial and gentle cast and Niagara swim were well improved suction toward vessel wall. You can see discussion. Vessel wall suctions were well improved with the use of arterial gentle cast, and Niagara swim. Arterial has a 4-side hole on different sides and a screw-shaped end hole. Gentle cast has 2 long holes on different sides. And then vessel wall suction was easily improved by these structures, particularly by side holes on different sides. Niagara swim lacks some side hole and presents an oval end hole structure with the largest angle. It was therefore considered that the catheter structure as well as the side hole are important. We considered our results suggest that the structure of the catheter's tip significantly influences vessel wall suction, and a careful tip design may improve the catheter's performance. Thank you for attention.